Alright, we are doing chapter 5, problem number 11. I'm going to go ahead and let the camera get into focus. Problem number 11 tells us to use the z-scores calculated in problem 10 in table A. What is the percentage of SAT scores that falls? And we're going to do, I believe, E and F. Alright, so in order to do E and F, we need to go back and do number 10, E and F. So the data I do have is I know that for SAT, the number of standard deviations in the distance that each of the following scores falls from the mean. I have to go back to number 9 to find out what the mean is. So does this tell me? Alright, I know that according to this problem, my mean is equal to 500 with a standard deviation equal to 100. I have that data, and then I want to go ahead and go to number 7, and I want to know for the SAT score, what is the z-score? So to capture the z-score, I need to do the z-score for 750 and for 380. Actually, no. I need, because I'm doing E and F, I need to know the z-score between 250 and 750. So I'll need to know 250, 750, and I'll also need to know 380. Alright, so let me do the z-score. And all the z-score is taking this score here, the given score, and putting it in standardized form. The way to standardize a score, you have, and I want to show you in the book here, this is the formula I'm using. Z is equal to X minus mu over the standard deviation. I want to wait for that to come into focus here. Page 109. For those of you who don't listen to the video. Alright? That will always be the case. Watch the placement of where you put your negative. So if I come back here, I'm going to have a Z, let's say for 250, is going to be equal to 250 minus 500 divided by 100. Okay. 250 let me get I'm using a calculator on my phone.
Was just 100. I'll let that come into focus. 380 minus 500 is equal to negative 120 divided by 100, which is just equal to negative 1.2. Negative 1.2. Now I will do my z-score of 750. Same formula, 750 minus 500 divided by 100. Alright, that's just going to be my 250 divided by 100, so that's going to be positive 2.5. Alright, now that I have all of my z-scores, I can then go to the next part of the problem. And so the rest of the remainder part of the question asks you to then, using those scores, what's the percentage of the SAT scores that fall either 5 4 or specifically between 50 and 750? So the very first thing I do, and bear with me because I'm holding this in my left hand, but you want to draw your normal distribution curve. And remember with the normal distribution curve, it is perfectly symmetrical, meaning that one side of it is exactly like these lines
a normal distribution curve is that it is symmetrical, has mode, the mean, all the same. Alright, and we get the probability score of, I'm sorry, .5 here, a negative 1.2. I'm just marking the ones we had before, and then a 2.5 here. Alright, so if I want to know the scores that fall between 250 and 750, and I know that these two correspond with 2.5 and 2.5, I am literally only trying to find the area between here and here. And I can go to the table in the back of the book, and I know I can find the distance from here to here, which would have to be the same distance from here to here. And then I can just add. So if I go to the book, the first column is going to tell me the area between the mean and the z-score. That would be the area from the mean here to the particular z, whether it's on the left or the right. That gives me that area. The second column gives me the area beyond that. That's column C. So if you want to know how to read this table, there's a B and a C here. You can look over here and it'll explain it to you. Right? I am now looking for 2.5. I go, there's 0.85. I'm going to go down, go down, go down, go down. 2.5, I come to 2.5. I know then, looking at 2.5, that the area from the mean to that point is 49.38. This area here is 49.38. Okay, so if I want to know the area between these 2 points, and they're exactly the same, this is positive 2.5, this is negative 2.5. I can just take 49.38 and double it. And when I do that, I end up with 49.38 times 2 gives me 98.76. So the area between 250 and 750 is 98.76. Because this is 49.38 as well. All right, let's go to the next problem. The next one asks us for 380, every score that's 380 or higher. Let me draw out another distribution curve. I'm going to put the camera down, sorry. I'll just go ahead and set it up. Probably should make a whole bunch of these and do them beforehand. Alright, and because I'm going with 380 here, I'm looking for 380. I go back, okay, my 380, once I standardize it, I get a negative 1.2. So if I go over here, I know I put it on the one above, I've got a negative 1.2. I can now, what I do know is, so what I'm trying to find out is 380 or above. So I'm trying to find out everything shaded to the right of this point, which would be all of this area. All right, if I know this entire thing is 100%, and I know the tables will actually tell me, based on this z-score, what's in this little tail here, I can calculate it that way. So if I go to the tables looking for 1.2, and I find them right here, 1.2 corresponds with 38.49, right?
That is 38.49. All right, so that area there is 38.49, and I want to know what the rest of the area is. I can simply take my 100. Actually, you know what? Let me back up. The 38.9 is this area. I didn't mean to draw that there. All right, 38.49 is that area. So I have 38.49. Sorry, I wasn't paying attention as I drew my picture. 38.49 is the area from here to here. And then I know this area here, if this is all 100 underneath the curve and I'm taking exactly half of it, I know this is equal to 0.5 or 50% or 50%. All right, if I add the two, I then come up with 50 plus 38.49, which is equal to 88.49%. So a score of 380 on this particular IQ test, the number of people who scored above a 380 would be 88.49%.